Uh, in other words, we can comment on this node. Let new node point to whatever this node was pointing to, right? So of course the new node is node B, and this node is node A, right? And on the next line we can say, and let this node point to the new node, which is basically kind of reflected by the name of this variable. So that's the outcome of us trying to insert the new node between A and whatever comes after it. It'll work. Next iteration in this project is going to be how about we create yet another node, node C, right? And if we want to create a list which says A points to B, B points to C, and C points to null, something like that, to complete a list like that, perhaps what we can do then is to say node A insert node C, and then node A insert node B. That should work. That should work. Let's find out if we could do something like this now. If we could add
node B, insert node C.
Yes. So the way it's done is that
Node B, you got A twice.
absolutely yes. Exactly right. Exactly right. And that's correct. So what is happening here is let me clean this up a little bit. So so here it is. The situation is like this. We create, as you can see, we create A, B, and C independent. We create all of them, right? So what happens after that, after we create A, B, and C? So let's say potentially this is node B, and let me take another copy of this, right? And this is arguably node C. And they're all existing somewhere in memory, and this one originally also pointing to null. So this is what we have at the beginning. By the end of construction node A, B, and C, this is what we have, two independent objects. The next step that we take is that we tell A, why don't you insert C in front of you? And that's exactly what it does. It just makes this link. The outcome of this insert is that we link A with C. Then we call A again and say, A, this time we want you to insert node B. We want you to insert node B. And in this case, what's going to happen is that first, this value, which already pointing to existing member of our list, is going to be used here. So this value already is known. So the first line of insert will make sure that what it does, right? So the first line there, what it's going to do is going to point B to C. That's what it's going to do. The first line of insert, this first line. The second line of insert is going to basically take this out. I'll just erase this, I guess, right? Replace this pointer with pointer to B. And so now we have it. A points to B and points to C. That's precisely what happens as a result of two calls to insert. Insert once and insert twice. And I did it backwards. First I took A and inserted C. Then I took A and inserted B. Because first there was A pointing to C, now A inserted B in front of itself, and now A points to B, B points to C. Which is what we were thinking maybe if we want to do this. Let's verify it real quick, should we? Right? So let's verify this. Let's test this the following way. Let's go to our main function here, and we could have another function, maybe node a dot print, just print, okay, which supposedly will print all values. Should print this, and let's initialize it like 1, 1, 1, 2, 2, 2, and 3, 3, 3. So the result of this print should be 1, 1, 1, 2, 2, 2, 3, 3, 3. How about that? Let's try this. So again, we go to our design and say, okay, let's print values in the list. All right. Void print no parameters. It's also a const function, which I will cover in a few minutes after we finish with this. Semicolon. So we'll take its signature here, and we'll go to our implementation file. So far we only have a constructor and this crazy insert. Then we are going to add this brand new function and say, okay, it's easy to print the value. It's simply, std cout, right? Print whatever the name, data, right? Just print the data, and maybe print new line. Okay, but then if there is another node, if another node exists, right? In other words, if the next node is not null, right? If the next node is not null, then simply say, hey, p node, you're next. Go ahead and print whatever you have. And so this function will be again invoked on the next node. If there's a non-null pointer to another element in the list, it will be again invoked. But every time we make this call, we print the data. Then, of course, we also need to perhaps go to our node.header here and say include IO stream, so that we can use the stream output anywhere we want. How about this? Let's see if this works. So here's the main function, insert. Hopefully this will do something useful. Build, right? And then, you know what, I need to get rid of those warnings of all in this project. I'll do it in the break. Control F5, execute. So there it is, 1, 1, 1, 2, 2, 2, 3, 3, 3. But then the recursion stops after we hit the node which no longer has the next pointer. Yes, Ryan.
The integer data that you have, apparently it's stored all the nodes. How does I don't see where in the code that data has all the
oh, how it gets populated?
Yeah, how does
right here, 1, 1, 1, 2, 2, 2, 3, 3, 3, because look at the constructor, right? Good question. That's where it gets populated. When the constructor of each node is invoked, it accepts the value. This is where it gets populated, right here. So all the nodes are constructed with 1, 2, and 3.
Oh, and then on the bottom of that, on the member initializer list, this is data then inside.
Yeah, the data accepts this new value.
Okay.
So nodes immediately are constructed with the values that we want them to have. We don't have much functionality right now to manipulate the data. There's no way to update or change it. All we do is just like able to print it. But the list works already because we say, hey, root, why don't you print the whole list? And it can. It can now go here and do it through this little, print your data. And if there is another element on the list, just call it. Just say, hey, another element on the list, print yourself. And this will print its own data, but also will check if there's another element. So it will be recursively making calls, and as soon as we hit null, this will never happen, and we just return from this function. Like, we could use a return statement that doesn't return anything, but we do return from each call, and we just return. So if I build this, then run it, what happens is that the first node is invoked, it prints this, then the next one prints this, the next one prints this, and we're just making calling. At the end of it, what happens is that all of them return at once. Return, and we unwind those stack calls, and we're suddenly back in main, right? So that's the way it operates. Let's see.